probes. Let's have a look. Woohoo! Look at that. Doesn't that look beautiful? Well, we've got ourselves various size near-field probes. They'd be the H-field. They'd be the magnetic ones, and it's probably, I assume, that we'd have an E-field one as well, or they might all be H-field. Have to have a look. Anyway, we've got ourselves a little wideband amp. There it is, 3 meg to 3 gig. Nice. That'd be fairly linear. So you basically, well, I'll explain and maybe demo this in a minute, but it looks like we've got an SMB connector on the end here, and we whack that over to the RF input, and then we hook the RF output, of course, up to our spectrum analyzer, and we can get do EMC pre-compliance with this sucker. There we go. We've got ourselves an adapter cable for our spectrum analyzer and a USB cable to power it. And let's have a look. We've also got a manual here, near-field probes. Yeah, H and E field. Okay, so yes, the smaller one must be the E field probe, because there's two types of measurements you can do with these things. H field, which is your magnetic field measurements, and E field, E for electric, of course. So you can do your electric field measurements, and they're basically two separate tests. And the reason you're going to get different size, I assume that these are all your H field ones. The reason you get different size ones is that you get better coupling with the big ones, but with the smaller loop, that'd be, so we'd have our loop around there. This one's smaller, and this one's smaller again. For the magnetic H field, you can pinpoint more easily exactly where your issue is with the smaller one. So that's why you get a couple of those, whereas you don't need that with the E field. Just the one will do the trick. So these are designed for EMC pre-compliance. So basically testing your own product in-house before you go and spend your thousands or tens of thousands of dollars to get it actually qualified at a proper EMC test lab. And the interesting thing about these is that not only can you use them to pick up magnetic fields in EMC, you can use them to generate as well. So you can, feed the signal. You can actually feed a signal and like sweep a frequency into here, and you can generate stuff. So if you got yourself a PCB, it's just a random PCB lying around, then you can actually generate a field in here and actually try and couple that into your product, so you can test for electromagnetic conformity in that way, that external magnetic fields at a certain frequency, or as I said, you can sweep it over a frequency, don't interfere with your product under test. So they can be used for sensing fields as well as generating them as well, if you want to use them in the reverse direction. And these go for under $400. You can actually buy them on Amazon. I just had a quick squeeze. I'm not sure what the price is anywhere else, but certainly people are selling them on Amazon, and you get a CAL certificate with it as well. And these are our 4 probes. Yeah, we've got our 3 H field probes. So I assume H20 is like the 20 millimeter diameter, 10 and 5. I'm assuming that's what those mean. So the 3 H field probes over the full 3 gig frequency range, or 300K, actually 300K to 3 gig, and our E field one as well. But if we have a look at the manual, we can probably find that the E field is different. Yes, first page, here we go. This is what I'm talking about. So what your magnetic or H field probes are going to give, they're going to give an output power in dBm versus frequency. So this is the response for the different size ones. So there's a 20 millimeter one like that, which drops off at about a gig there or thereabouts, and the various sizes, and then for a given field of 1 microtesla. So if a known input field, a known input magnetic field in teslas will give out a certain output power dBm versus frequency, whereas your E field probe, your electric field probe, is basically entirely different, because it's an electric field which is volts specified in volts per meter. So once again, you'll have an output power here versus frequency for a known field, a fixed known input field of 1 volt per meter. But not only are they useful for like just bare PCBs like that to check traces and and components and all sorts of aspects to your PCB design, they can be used on final enclosures like this. So you can actually go around and find that, okay, we got some leakage around these RCA ports here, or around our HDMI, for example. So, but it's an art in its own right, actually doing a proper EMC pre-compliance measurements. And I could do, there'd have to be hours and hours of instructional videos to actually, to go through all the ins and outs of that. But yeah, these things are really very nice. If you're developing products, it's a really cheap way to, make sure you're at least in the ballpark before you go to your EMC test house, and you can spend, like time and money. Of course, time is money, so even more money by going there. So you can make sure your design is, have a good chance of success. But of course, you've got to understand the various standards and specifications and how to do the measurements and all that sort of stuff. So maybe all that stuff is on the TechBox website. So with a cheap spectrum analyzer like this Rigol DSA 815 and a near-field probe kit and the listen devices, I've done a separate video on, also from TechBox as well, which I'll link in down below for EMC pre-compliance. I already have one video on that, but these are your for under $400 to get one of these near-field probe sets, you can do complete EMC pre-compliance for like well under $2,000, and that is, like, trust me, that's unheard of. I mean, it cost an absolute fortune just 5 or 10 years ago. You had to have a real high-end spectrum analyzer, but now they're really cheap, and these have got you can buy the EMC pre-compliance plugin for this as well, which helps you more easily meet the standards and stuff like that. But anyway, this won't be a proper video on EMC pre-compliance, just playing around here to see what we do. And I've got my E-field probe in here, and we can probe around and actually have a look at not a circuit, but just the interconnecting cables and the spectrum analyzer itself. Watch what happens if we put this over our cable here. Look at that. We're picking up something at 900 megahertz there, and you see it has to get very close. This is on the shield of the cable here. This is why it's called a near-field probe, because it has to be near to the product, so or near to the item that you're trying to test. And right at the BNC, USB down in there, and at that headphone output jack. Whoa, look, if I stick it in that headphone jack, it's really going off the scale, and nothing's sort of escaping from our end connectors here or anything like that. It's just fine. But our around the USB and everything here, well, there's something huge happening at 900 megahertz. And then we can have a play around with this HDMI board we were looking at before, and we can probe over that. I've got like the full span here, and we're probably not going to see a huge amount. Get over the crystal there. Yeah, there's something happening down at the low end, as you'd expect. So this is over the full 1.5 gig. So let's go down to the low end and see what's happening down there. If we probe our crystal again, bingo, look, we've got a peak there at 36.85 megahertz. And that's not surprising, because this is a 12.28 megahertz. So one third of that frequency. So we must be getting a harmonic there. So expand that out. And here we go. We got our fundamental here around our clock there, our crystal, and that's at 12.2. Well, it's marked 12.28. We're getting 12.23 megahertz there, near enough. And then we've got one of our harmonics here at 36, at a multiple of that, of course, 3 times that, at 36.96 megahertz. So you can actually probe around not only parts, but you can follow traces and things like that and find any signals on your board. Really quite neat, and it just lets you do. And if you know what the standard is, and you know that, it's not, I screwed up the layout on this and it wasn't supposed to emit there, and all that sort of jazz, then yeah, you can find this stuff really easily with these sorts of near-field probes. Now, the way you typically use these is that your E-field probes are basically for very close direct contact here, which is why we're seeing nothing until we go like directly over the crystal there. So you can pin, like track down like maybe individual pins or individual traces on large scale stuff. It's harder on, you know, really fine surface mount stuff like this to try and pick it up. Whereas your magnetic field, your H-field probes are designed to pick up your larger loop areas, like your ground loop areas, which is one of the big things for EMC compliance, is that you have to keep the golden rule of PCB layouts, keep your ground loop or your loop areas small. So and that means going from your power supply all the way out. The loop area includes your ground on here, includes your ground system plus the power wires to get there and any signal stuff. So it's an entire, you know, where the current flows in the entire loop, and that's where these H-field or magnetic field probes pick up. So we're picking up a lot more crap, as you can see, going around here with our H-field probe. We're not just picking up that individual crystal, so we're picking up all sorts of crud on here due to, you know, other clocks or other signals that are all looping around this board right back to the power supply. So that's the difference between the H-field probes and the E-field electric probes. And one of the things you can do too is you can use demodulation functions on these. A lot of the old greybeards do this. They will plug in some headphones here. That's why it's got a headphone port, so you can demodulate the signals and you can actually listen to it. And, you know, all your greybeards who go around, you know, scanning the board, listening in their headphones, stroking their beard with their other hand, with their third hand, and going, yeah, there's your problem. And if you're still a bit confused over the H-field versus E-field thing, well, just remember what EMI is, what it stands for, electromagnetic interference, or EMC, electromagnetic conformity. Electromagnetic, there's electric fields and there's magnetic fields, and depending on whether you're near field, far field, whatever, or high voltage, low current, or high current, low voltage, that kind of stuff, that depends on which field is going to dominate and which you can actually measure. So generally speaking, at high voltage, low current stuff, the E field is going to dominate, so you're going to want to use an E field probe, for example. But for high current stuff, then, which is going to be, as I said, like, you know, loop area, big loop area on a PCB, and, you know, there's a chip just drawing, you know, huge gulps of current or something like that, generating big magnetic fields, then generally at a specific distance, the H field, the magnetic field, is going to dominate. So you're going to want to use a magnetic field. So there you go, just keep that in mind. EMI, electromagnetic. So thank you very much, TechBox. This is an awesome set. It's going to come in real handy in the lab. Oh, there it is down there. It's empty. But yeah, well worth the dollars if you're doing EMC pre-compliance. As I said, under $2,000 for something like this. You can do it really well. I mean, it might seem like, you know, a lot of money, but it saves you a ton of money, one of these things, and pretty essential if you're doing product development. And it's also essential to get the calibration certificate with it as well, so you know the exact performance of this. So because you're actually doing quantitative measurements here, trying to at least see if you're going to get in the ballpark of passing your standards. So you know you're also paying for the calibration and certification of these things. So very handy. I'll link in these down below at TechBox